Hello friends, I am Jay Rathod welcoming you in the solution session of assignment 3.2. This assignment is based on finding inverse of matrix using row operation. To get inverse of any matrix A, we have to write in the form of A is equal to IA form, and then we have to apply series of row operation on the matrix A and the first matrix on right hand side I to get the reduced row echelon form of matrix A, which is normally identity matrix. Then we will get A inverse on the right hand side into A form. So when we get I is equal to A inverse A form, we will get our A inverse. And now to convert the matrix into its reduced row echelon form, or we can say identity matrix in this case, the steps are shown here. The very first step is to get leading one at A11 point using any operation depending on the question. And when you get the leading one at A11, you have to notice the value of K, which is just below the A11, or we can say A21. So after completing your first step, you should move to the second step, in which you have to get 0 at all other elements in first column. In this case, our A21 element, using the operation R2 gives R2 minus KR1, and the value of K is take from here, right? So using this operation, you will get 0 at A21 as well as the value of M, which will be helpful in the third step. But note that when we set leading 1 and 0 in the first column, now we can't use the first row to get leading 1 at second row. Okay. Now to get the leading 1 at A22 point, we forced to take common M from the first row. So we have to apply R2 gives 1 by M R2. So after this operation, we will get leading 1 at A22 point as well as the value of N at A12, where we have to get the 0 in next step. And for that, our final operation is R1 gives R1 minus N R2. So tada, you will get the reduced row echelon form, or we can say identity matrix on the left side, and on the right side you will get A inverse. And please don't forget to write A over here. Okay, so hopefully you are ready to solve the assignments. So let's move to the questions. Let's start to solve our first question. In question, one matrix A is given I0, 0, I by 2, and we have to find inverse of this matrix. And the first step to get this is A is equal to IA. Now we should convert our left side into the identity matrix, and the steps to get that is shown on the right side. The first step is to get leading 1 at A11 point. We have minus I, right? So to get 1 at this place, we should multiply minus I to the entire first row. I mean to say, we have to take operation R1 gives minus I R1. So let's multiply minus I to the first row. In this operation, our second row will be as it is. So second row is as it is. Now I into minus I will give us minus I square, or we can say 1. 0 into minus I will give us 0. 1 into minus I will give us minus I, and 0 into minus I will give us 0. So we complete our first step. Now in second step, we need to get 0 at to 1, A to 1 point. We already have 0, so we don't have to worry about the second point. Now let's move to the third aim, in which we need to get leading one at A to 2 point. So think about it. How we get leading one at A to 2 point? We should multiply the reciprocal of this part, right? Or we can say we have to multiply 2 by I, so it will become 1. Okay, but what do you mean by 1 by I? It's actually minus I. That means we have to multiply minus 2I. Or we can say we have to take operation R2 gives minus 2I R2. And in this operation, our first row will be as it is. So let's write down as it is. Now we have to multiply minus 2I to the second row. So 0 into minus 2I will be 0. I by 2 into minus 2I will be 1. 0 into minus 2I, 0, and minus 2I. And in last step, we need to get 0 at A12 element. And we already have A1 to 0, right? So we complete our steps, and as you can see, we get I is equal to A inverse A form, which suggests that our A inverse is minus I 0, 0 minus 2I. Let's see the options. Option B is your right answer. Ta-da! Here we have one interesting and concept clearing question. The question is like, on a using elementary column operation, C2 gives C2 minus 2C1. In the following matrix equation, which is in the form of X is equal to AB, we will get one of the following form. Okay. Now, since we are using column operation on X is equal to AB system, we have to remember one thing. We can apply this operation simultaneously on X and second matrix B of the product AB on the right hand side. Matrix A will be as it is during this elementary column operation. Clear? Now let's apply the operation to the matrix equation, and the operation is C2 gives C2 minus 2C1, right? That means we have to multiply the first column to the minus 2 and then add to the second column. So 1 minus 2 is minus 2, 2 minus 2 is minus 4, and same thing we will apply to the matrix B. We will multiply first column minus 2 and then add to the second column. 3 minus 2 is minus 6, 2 minus 2 is minus 4. So our matrix equation become 1, 2, and the second column will be transformed to minus 5, 0. Matrix A will be as it is, and the second matrix B will be 3, 2 and minus 5, 0, which is same as option D. So the correct answer is option D. Ta-da! In our next question, we have to find inverse of A, and for that we have to write the form of A is equal to IA. So here we have the form. Now our first step is to get leading one at A11 point. For that we have to take two operations. First of all, minus 2 to the second row, then add. So here we will get minus 1. So we have to take minus 1 common from first row. So let's do it without wasting time. First of all, we will operate R1 gives R1 minus 2R2. So you have to multiply minus 2 second row, then it will add to the first row. 3 minus 2 will be minus 6. 1 minus 2 will be minus 2. Same thing with another matrix. 0 minus 2 will be 0 and 1 minus 2 will be minus 2. So after simplification, we will get our second row will as it is and first row become minus 1, 0, 1 and minus 2. But still we don't get leading one at A11. For that we have to take common minus 1 from the first row. So after taking this operation, we will get 1, 0, minus 1, 2 and second row will be as it is. So finally our leading one as well as the value of k. Okay, so now we should move to the second step, in which we need to get 0 at A21, and for that we have to take the operation R2 gives R2 minus k, which is 3 in this case, R1, right? So this process we have to multiply minus 3 to the R1. So let's multiply minus 3 to the first row and then add in the second row. 1 minus 3s are minus 3, 0 minus 3s are 0. Same thing on the right side, minus 1 minus 3 become plus 3, 2 minus 3 become minus 6. So after simplification, our first row will be as it is and the second row will be 3 minus 3, 0, 1 plus 0, 1, 3 and minus 5. Oh my god, we already get identity matrix on the left side. That means we get our I is equal to A inverse A form, which suggests that our A inverse is minus 1, 2, 3 minus 5. Ta-da! Option B is your answer. In this question, we have to find inverse of the given matrix, and for that, first of all, we have to write in form of A is equal to IA. So here we have A is equal to IA form. Now first of all, we need to get leading one at A11 point. Bhagwanni dayathi, we already have leading one at A11 point, right? And from that, we also get the value of k. So 3 is the value of k. Now in second step, we need to get 0 at 211 point, right? And for that we need to take R2 gives R2 minus k R1, or we can say minus 3 R1. So let's take this operation. First of all, write down what we already have. Here we have. Now we need to multiply minus 3 to the first row and then add to the second row. So 1 into minus 3 will be minus 3. 3 into minus 3 will give us minus 9. Same thing we have to do with the right hand side. Multiply minus 3 and add to the second row. 1 into minus 3 will give us minus 3. 0 into minus 3 will give us 0. So we will get first row as it is, 1, 3, 1, 0. And in second row, 3 minus 3 will be 0, 10 minus 9 will be 1, 0 minus 3 will be minus 3, and 1 plus 0 will be 1. So tada! We complete our second step. Now we can use the first row. The third step is get leading one at A22 point. Bhagwanni daya farithi hai. We already have leading one at A22 point, and we will get the value of n is equal to 3, which will be useful in the last and the fourth step. in fourth step we need to get 0 at a12, and for that we are going to take operation r1 gives r1 minus n, which is 3r2, right? We know that for doing this operation, first of all we have to write what we already have. So here we have this. Now we have to multiply minus 3 to the second row. So let's multiply minus 3 to the second row and then add to the first row. So we have to add the first row. So here 0 into minus 3 will give us 0. 1 into minus 3 will give us minus 3. Same thing we have to do with the another matrix. Minus 3 minus 3s are plus 9. 1 minus 3s are plus 9. Sorry, minus 3. So if we simplify, we will get second row as it is 0, 1, minus 3, 1. Only first row is changing, right? So 1 plus 0 will be 1, 3 minus 3 will be 0, 1 plus 9 will be 10, and 0 minus 3 will be minus 3. So tada! We get I is equal to A inverse A form, which suggests that our A inverse is 10 minus 3 minus 3, 1. Option B is your answer. In this question, we have to find inverse of minus 6, 5, minus 7, 6. And for that, we need to get A is equal to IA form. Here it is. Now, our first step is to get leading one at A11 point. And as you can see, if we take minus 6 common from the first row, it will become a little bit difficult for calculating further, right? So it's preferable that we multiply minus 1 to the first element and add to the first row. I mean to say, we should take operation r1 gives r1 minus 1 r2. And for that, first of all, write down what we already have. So here it is. Now, as we plan, we have to multiply minus 1 to the second row and then we will add into the first row to get leading one. So minus 7 into minus 1 will be plus 7. 6 into minus 1 will be minus 6. Same operation we will do with the another matrix. Multiply minus 1 and add to the first row. 0 into minus 1 will be 0. 1 into minus 1 will be minus 1. So we will get our second row as it is minus 7, 6, 0, 1. And our first row will be minus 6 plus 7, 1, 5 minus 6, minus 1, 1 plus 0, 1, and 0 minus 1, minus 1. So finally, we complete our first step. We get leading one at A11 and get the value of K as a minus 7. Now, we should move to the second step in which we need to get 0 at A21. And for that, we have to operate R2 gives R2 minus KR1. We can say R2 gives R2 minus K, which is minus 7. So it will become plus 7 R1, right? For that, let's write down which we already have. And here it is. Now, let's operate R2 gives R2 plus 7 R1. That means we have to multiply 7 to the first row. So here we have to multiply 7 to the first row. Then we will add into the second row. So 1 into 7 will give us plus 7. Minus 1 into 7 will give us minus 7. Same thing with the right matrix. So 1 into 7 will give us plus 7. minus 1 into 7 will give us minus 7. So in this process, our first row will be as it is and the second row will be 0, minus 1, 7 and minus 6. So tada, we complete our second step also. Now we need to get leading one at A22 point, and for that we have to take minus 1 common. I mean to say we have to take R2 gives minus 1 R2 operation. So in this operation our first row will be as it is and our second row become 0, 1, 7 become minus 7, minus 6 become plus 6. Finally we get leading one at this point, as well as we get the value of n as a minus 1. So for the last step we have to take R1 gives R1 minus n, or we can say plus 1 into R2, right? So let's take this operation, and for that we have to write down what we already have. Here it is. Now we have to simply add the second row to the first row. So it will become 1 plus 0 and 1 minus 1 plus 1. And same thing we have to do with the second matrix. So let's add minus 7 and plus 6. Then finally, after simplification, we will get 1, 0, 0, 1. On right hand side, we will get minus 6, 5, minus 7, 6. So tada, we will get I is equal to A inverse A form, which suggests that our A inverse is minus 6, 5, minus 7, 6. Option A is your final answer. In this question, we have to find inverse of matrix minus 3, minus 4, 2. For that, first of all, we have to write the form of A is equal to IA. Then start to get reduced row recurrent form on the left side. For that, our first step is to get leading one at A11. And here you can see the only option is to take 2 common from the first row. So let's take the operation R1 gives 1 by 2 R1. In this operation our second row will be as it is. So let's write down as it is, and the first row will be 1 minus 3 by 2 will give us minus 3 by 2, 1 by 2 and 0 by 2, or we can say 0. So here we complete the first step. We get leading one as well as the value of k, which will helpful in the next step. In the second step, we have to get 0 at 2, 1 using the operation R2 gives R2 minus k, which is minus 4 in this case. So it will be plus 4 R1. It means to say we have to multiply first row with the 4 and then add to the second row. So here we'll get 1 4s are plus 4, minus 3 by 2 4s are minus 6. Same thing on the right side will give us 1 by 2 4s are plus 2 and 0 4s are 0. So our matrix will become something like this, in which our first row will be as it is and the second row will be 0, minus 4, 2 and 1. Now we can't use the first row, right? So to get leading one at A22 point, we should take minus 4 common from the second row. That means we have to take R2 gives minus 1 by 4 R2 operation. So now we have to take minus 4 common from the second row, and first row will be as it is. Then you will get 0, 1, minus 1 by 2 and minus 1 by 4. So we complete this third step, we get leading one as well as the value of n. So quickly move to the fourth step, in which we have to get leading one at a12 using operation r1 gives r1 minus n, or we can say minus 3 by 2, so it will be plus 3 by 2 r2, right? Seems tough thing, but we have to do this. We have to multiply second row to the 3 by 2 and add to the first row. Let's do it. 0, 3 by 2s are 0, 1, 3 by 2s are plus 3 by 2, minus 1 by 2, 3 by 2s are minus 3 by 4, and minus 1 by 4, 3 by 2s are minus 3 by 8. So in simplified matrix, our second row will be as it is. First row will be 1, 0, minus 1 by 4 and minus 3 by 8. So here we get I is equal to A inverse A form, which suggests that our A inverse is minus 1 by 4, minus 3 by 8, minus 1 by 2, minus 1 by 4. Or we can say we can take minus 1 by 8 common and we will get 2, 3, 4 and 2. Ta-da! Let's see the option. Option A is your final answer. In this question, you have to find inverse of matrix 3 minus 2 A4, and the first step is write in the form of A is equal to IA, and here it is. Now our first step is to get leading one at A11 point. Actually we have one, but it is in the second row, so it's preferable to exchange the second row with the first row, right? So the preferable operation is R1 exchange with R2. So the second row, which is 1, 4, now become your first row. 0, 1, okay, and the first row is now your second row, right? So we complete our first step. We get leading one, the A11 position, as well as we get the value of k, which will helpful in the next step. The second step is get 0 at 21 point, and for that the preferable operation is R2 gives R2 minus KR1. So here now R2 gives R2 minus K, or we can say 3R1. So first of all, let's write down what we already have. Here it is. Now we have to multiply minus 3 to the first row, and then we will add into the second one. So 1 minus 3 will be minus 3, 4 into minus 3 will be minus 12. Same thing on the right side, 0 into minus 3 will be 0, and 1 into minus 3 will be minus 3. Now it's time to simplify. Simplified matrix. First row will be as it is, 1, 4, 0, 1, and in second row we will get 0, minus 14, 1 and minus 3. So here we complete our second step. Now we can't use the first row. It's time to get leading one at A22 point, and for that we should take minus 1 by 14 common. So our next operation will be R2 gives minus 1 by 14 R2. So in this operation our first row will be as it is, and our second row will become 0 upon 14, 0. Here we will get 1, then minus 1 upon 14 and 3 upon 14. Second step is also completed. We get leading one as well as the value of n, which will useful in the next step to get 0 at a12 point. In the operation of r1 gives r1 minus n, or we can say 4 r2. So let's do this operation. First of all, we have to write what we have. Now we have to multiply this minus 4 to the second row and then add to the first row. So 0 into minus 4 will be 0, 1 into minus 4 will be minus 4, and same thing with the right side, multiply with minus 4, then add to the first row. Minus 1 by 14 into minus 4 will be plus 4 by 14, and 3 by 14 into minus 4 will be minus 12 by 14. Now we have to simplify this matrix to get final answer. Here our second row will be as it, and our first row will be 1, 0, 4 by 14, and 1 minus 12 by 14 will be 2 by 14. So yes, we get I is equal to A inverse into A form, which suggests that our inverse of matrix is 4 by 14, 2 by 14, minus 1 by 14 and 3 by 14. Option A is your final answer. Ta-da! Here we have one concept clearing question. Using elementary row operation, R1 gives R1 minus 3R2 in the following matrix equation, which is in the form of X is equal to A into B. We will have one of the following options. Okay. Here we are using row operation on X is equal to AB system, right? So we should apply the operation simultaneously on X and on the first matrix, which is A, the product AB on the right hand side. This operation, our B will remain as it is. Clear? Now let's apply the operation on this matrix equation. We have to apply R1 gives R1 3R2, right? That means we have to multiply second row to the minus 3, then to the first row. So 3 minus 3 is a minus 9, again minus 9. Same thing on A matrix, 0 minus 3 is a 0, 3 minus 3 is a minus 9. So our matrix equation become minus 5, minus 7, 1, minus 7. And the second row will be as it is, 3, 3, 0, 3. And in this process, our whole matrix B will be as it is. So this will be our new matrix equation, which is exactly equal as option A. So your answer is option A. Ta-da! Here we have one simple question, but it taught us very good concept which will helpful to solve some 4 markers. In the question, we have a matrix which satisfies the matrix equation 4a cube plus 2a square plus 7a plus I is equal to 0 matrix. And we have to find A inverse. Now, to find A inverse, we need to form A inverse in this equation. And for that, let's multiply A inverse on both sides of the equation. Now, on the left side, A inverse into 4a cube will give us 4a square, similarly 2a, then 7. A inverse into A will give us I, don't forget this I, plus A inverse into I will give us A inverse, and on right side A inverse into 0 matrix will be 0. Now we need to find A inverse, so let's make it subjective. So simply A inverse will be minus of 4a square plus 2a plus 7i, which is option B. Tada! So if we have this kind of a characteristics equation, we can find out A inverse using the equation. And for that, we just need A square, matrix A itself, and identity matrix. Okay? So hopefully this information will helpful in the future. In this question, we have to find inverse matrix of 4, 7, 1, 2. And we know that our first step is to get in form of A is equal to IA. So here it is. Now our first step is to get leading one at A11 point, but we have 1 in second row. So it suggests that we have to exchange our first and second row. So let's do the operation R1 gives R2. So our second row, which is 1, 2, will become your first row. Same thing with the right side, 0, 1. And second row, which is 4, 7, 1, 0, will become your second row. So here we complete our first step. We get the leading one at A11 and the value of K is 4. Now we should go to get 0 at A21 point by taking the operation R2 gives R2 minus K, or we can say 4R1, right? So let's write down. Now multiply minus 4 to the add to the second row. So 1 minus 4 is a minus 4, 2 minus 8. Same thing with the 0 minus 4 is a 0 and 1 minus 4 is a minus 4. So let's, in simplification, your first row will and second row will become 4 minus 4 0, 7 minus 8 minus 1, 1 plus 0 1, and 0 minus 4 minus 4, right? So here we complete our second. We get 0 at A22 point and get the value of M, right? Now we can use first row. Our third step is to get leading one at A22 point, and for that we should multiply minus 1 to the second row. Let's multiply minus 1 to the second row. This operation our first row will be, and your second row will be 0 minus 1 into minus 1 plus 1, 1 into minus 1 minus 1, minus 4 into minus 1. We get leading one as well as the value of N. Now to move to the next step, the preferable operation is R1 gives R1 minus N, or we can say 2R2, right? So let's write down what. Let's multiply minus 2 to the second and add to the first row. So 0 into minus 2, 0, 1 into minus 2, minus 2. Same thing with the right hand side, minus 1 into minus 2, plus 2, 4 into minus 2 would be minus. When we simplify, our second row will and first row become 1, 0, 2, minus 7. So tada, we get I is equal to A inverse A form. This question is based on the property of inverse of matrix. In this question, matrix A and B is given, and we have to find the inverse of multiplication of B inverse and A inverse. Now if you remember that x into y's inverse will be product of y inverse and X inverse. So let's use the same property to solve our question. Our X is B inverse and Y is A inverse. So according to property, we will get inverse of A inverse and inverse of B inverse. Now we know that inverse of inverse will be matrix itself. So here we simply have to find A into B. So let's get A and B. Here we get A and B. Both are 2 cross 2 matrix. We know the matrix multiplication rules. These two numbers should be equal to each other and answer will be in the order of 2 cross 2. That means resultant matrix will have 2 rows and 2 columns. Now let's multiply 2 matrix. The first element is in first row, first column. So we have to multiply first row and first column's respective term. So 2 zeros are 0 and 2 ones are 2. Now the next element is in first row, second column. So we have to multiply 2 minus 1s are minus 2 and 2 zeros are 0. Similarly, the next element is in second row, first column. So select second row, first column and multiply respective terms. And the last term will be 0. So the resultant matrix will be 2 minus 2, 2, 3. Ta-da! Option A is your final answer. In this question, you have to find inverse of matrix 1, 2, 3 minus 5. The first step is write in the form of A is equal to IA. Then the next step is to get leading one at A11 point, and by the God grace you already leading one. So our first step is completed and we get the value of K, which is 3, right? Okay. Now let's move to the second step, in which preferable of R2 gives R2 minus K, or we can say 3R1, right? So in this operation, first of all, let's write down. We have to multiply minus 3 to the first row. So let's multiply minus 3 to, and then add to the second row. So 1 minus 3 will be minus 3, 2 minus 3 will be minus 6. Same thing on the right side. So 1 minus 3 will be minus 3 and 0 into minus 3 will be minus. So let's simplify. First of all, notice that our first row will be and our second row will become 3 minus 3, 0, minus 5 minus 6, minus 11, 0 minus 3, minus 3 and 1 minus 0, 1, right? Here we complete our second step. We get 0 as well as the value of n. Now we can't use first row. Now we should get leading one at A22 point. Using the operation, R2 gives 1 by m, or we can say minus 1 by 11 R2, right? That means we have to take minus 11 common from the entire section. In this operation, our first row will be and our second row become 0 by 11, 0, minus 11 by minus 11, 1, minus 3 by minus 11 will be 3 by 11, and here we'll get minus 1 by 11. We complete our third step. We get leading one at A22 as well as we get the value of n, which is 2. Now let's move to the fourth and last step, in which the preferable operation is R1 gives R1 minus n, or we can say 2r2. That means we have to multiply minus 2 to the second row. For that, first of all, let's write down. Now, as we plan, we have to multiply minus 2 to the, so multiply second row to the minus 2 and add onto the first one. So 0 minus 2, 0, 1 minus 2, minus 2. Same thing on the right side. 3 by 11 into minus 2, minus 6 by 11, and minus 1 by 11 into minus 2, plus 2 by 11. So, in simplification, our second as it is, and our first row will become 1, 0, 1 minus 16, 5 by 11, and 2 by 11. Yay! We get I is equal to A inverse A form. That means our A inverse 5 by 11, 2 by 11, 3 by 11, minus 1 by 11. B is your answer. Tada! In this question, the given matrix is 2, 3, 4, 6, and we have to find inverse of that matrix. For that, we should write down in the form of A is equal to IA. Then, the first step is to get leading one at A11 point. The only option to get there is by taking 2 common from the first row. That means we have to take R1 gives 1 by 2 R1 operation. This operation, our second will be as it is. And after taking 2 common, our first row will be 1, 3 by 2, 1 by 2, and 0 by 2, or we can say 0. So here we complete our first step. We get leading one at A11 as well as we get the value of k, which is 4. Now the second step is to get 0 at A21 by the operation R2 gives R2 minus k, or we can say 4R1. To do this operation, let's write down what. Here it is. Now as we plan, you have to multiply minus 4 to the first row, add to the second row. So 1 into minus 4 will be minus 4, 3 by 2 into minus 4 will be minus 6. On the right side, 1 by 2 into minus 4, minus 2, 0 into minus 4 will be. And now we should simplify. Our first row will be and our second row become 4 minus 4, 0, 6 minus 6, oh my god, 0 again, minus 2 and 1. As you can see, we get 0 on an entire second row. That means we cannot get identity form on the left side, which suggests that our A inverse does not exist. Okay, so the option D is your answer. This question, we have to find multiplicative inverse, or we can say inverse of the matrix 2, 1, 7. For that, first of all, we have to write in form of A is equal to IA. Then we have to move for the getting identity matrix on the left side. For that, the first step is to get leading one at A11 point. So we don't have any 1 in the first column, right? So first of all, let's get 1 at this point by multiplying minus 3 and then add to the second row, and then we will interchange the row, right? So let's take the operation R2 gives R2 minus 3R1. Here we get upper term as it is. Now we have to take the operation in which we are going to multiply minus 3 to the first row, and then it will add to the second row. So 2 into minus 3 will be minus 6, 1 into minus 3 will be minus. The same thing on the right side, 1 into minus 3 will be minus 3, 0 into minus 3 will be 0. So our simplified matrix, first row will as it is 2, 1, 1, 0, and in second row 7 minus 6, 1, 4 minus 3, again 1, 0 minus 3, and 1 plus 0, 1. So we get the 1, but not it is on the 8, 1, 1 place. We get 1, but not at A1, 2. So for that we have to exchange the first and second row. So we will exchange first row and second row. So our matrix will become 1, 3, 1 and 2, 1, 1, 0. Okay, so tada, we complete our first step. We get leading 1 as well as the value of k. Now we should move to the second step, in which we need to get 0 at a to 1. By applying the process, R2 gives R2 minus k, or we can say 2R1. For that we need the previous step. Then we will multiply the first row to the minus 2, and then it will add to the second row. So 1 into minus 2 will be minus 2, 1 into minus 2 will be minus 2. On the right side, minus 3 into minus 2 will be plus 6, 1 minus 2 will be. So here our first row is, and the second row will be 0, minus 1, 7 and minus. So we complete the second step. Now the third step is to get leading 1 on the A to 2 point, and for that we should take minus 1 common, or we can say we have to multiply minus 1 second row. In this operation our first row will, second row become 0, 1, minus 7, and so we also complete the third step. We get leading 1 as well as value of n. The last step is to get 0 at A1, 2, and for that we should take R1 gives R1 minus n, or we can say 1 R2, right? So we need to multiply minus 1 to the second, and then we will add it into the first. So 0 into minus 1 will be 0, 1 minus 1 will be minus 1. Same thing on the right side. So minus 7 minus 1 become plus 7, 2 minus 1 become minus 2. The final simplified form like this, which is the form of I is equal to A inverse A. Tada! Which suggests that our A inverse is 4 minus 1 minus 7, 2. D is your final answer. Here you have to find the inverse of matrix 1 minus 2, 3, 4. And for that you have to write A is equal to IA. Then we need to get identity matrix on the left side. First step for getting that is to get leading 1 at A11 point. ભગવાનની દયાથી આપણને 1 already A11 પર આપે છે. So let's move to the next step, and for that we need K, which is 3 at A21 point. Second step, we need to get 0 at A21 point by the operation R2 gives R2 minus K, or we can say 3 R1, and for that we have to write the same step. Then we have to multiply minus 3 first row. So let's multiply first row to the minus 3, and then add into the second row. 1 minus 3 is minus 3, minus 2 minus 3 is plus 6. Same thing on the right side. 1 into minus 3 will be minus 3, 0 into minus 3 will be. So now we have to simplify. First row will be, second row will be 3 minus 3 0, 4 plus 6 10, 0 minus 3 minus 3 and 1 plus 0 1. So here we complete our second step. We get 0. Now we should get leading one at A22 point, and for that you have to take 10 common from the second row, or we can say we should take operation R2 gives 1 by 10 R2, right? And in this operation our first row will be as it is. So let's write down. Second row will be 0 by 10, 0, 10 by 10, 1, minus 3 by 10, minus 3 by 10, 1 by 10, 1 by 10, right? So we get the leading one and the value of n minus 2, right? So we should take the last step, in which you have to take the operation R1 gives R1 minus n, or we can say minus 2 will become plus 2 R2. To get this operation we have to write the last step, then we have to multiply second row, and then it will add to the first row. So 0 into 2 will be plus 0, 1 into 1 plus 2 will be plus 2. Same thing on the minus 3 by 10 into 2 minus 6 by 10, 1 by 10 into 2 plus 2 by 10. Now we just have to simplify, and our second row will be, and our first row will be 1, 0, 4 by 10 and 2 by 10, which is in the form of I is equal to A inverse A, which suggests that our A inverse 4 by 10, 2 by 10, minus 3 by 10, or we simply take 1 by 10 common and we get 4, 2 minus 3, 1. Let's see, the option A is the correct option. Tada! Friends, here we complete assignment 3.2. Hope you get idea how to get inverse of matrix of 2 cross 2 using row operation. Still, if you have any doubt, feel free in the comment section or contact me on a WhatsApp. Okay then, tata, bye bye, take care and Jai Mata.